Let's take a look at this trig graphs question. Question number 5, the graph of f of x is equal to 2 cos x plus p is sketched below, for x is plotted between minus 90 degrees and 180 degrees. Question 5.1, write down the amplitude of f. So to calculate the amplitude of a graph, we say the maximum minus the minimum divided by 2, and that's going to be my amplitude. Now we can read off the graph, the maximum value here is 2 minus the minimum value is minus 2 divided by 2. That's my amplitude. So 2 minus minus 2 is 2 plus 2, which is 4 divided by 2, which is 2, and that's my amplitude. Question 5.2, write down the value of p. So p is this unknown value here, and that is referring to, because it's in the bracket, it's referring to the left or right shift of this function. Now there's two ways to solve it. One is through inspection, the other is through substituting and solving. So let's take a look at the first option, through inspection. So the way that you would solve it through inspection is by first remembering how a normal cos graph would look. A normal cos graph starts at, or would start at 1 or 2 and then go downward. However, this maximum has now been shifted 45 degrees to the left. Now you need to remember that if it's being shifted to the left, then the value inside the bracket is going to be positive. So the answer is going to be plus, because it's being shifted to the left. And how many degrees has it been shifted? It's been shifted 45 degrees. So P is equal to 45 degrees. The other option is to solve it through substitution. So let's take a look at that. So what we do here, pick a coordinate. Now I'm going to pick the coordinate that we just used. Let's go with negative 45 and 2. So this point right here. So my coordinate is negative 45 and 2. That's my x value. That's the y value. So the function is y is equal to 2 cos x plus p. So I'm substituting 2 is equal to 2 cos, x is minus 45 plus p. Now I'm going to divide both sides by 2. That's going to disappear. I'm going to be left with 1 is equal to cos of minus 45 plus p. Now I'm going to take the cos over, the arc cos of 1 is going to equal minus 45 plus p. The arc cos of 1 is 0, and that's equal to minus 45 plus p. Now take the negative 45 over, you get 45 degrees is equal to p. Now let's take a look at question 5.3. Question 5.3 reads, given that g of x is equal to sine 2x plus 1, write down the period of g. So to work out the period of a graph, for a sine graph, it's going to be 360 divided by the coefficient of x. So that's going to be 180 degrees. For cos, you would do the same thing, 360 divided by the coefficient. But for tan, it's 180 divided by the coefficient. Question 5.4, on the system of axis provided, it's not provided, we'll draw it on here. Sketch the graph of g of x is equal to sine 2x plus 1, and they've given us the domain. Now, there's a few ways to do it. However, I feel the easiest way would just be to use our calculator and get coordinates. So, since we've been given the domain, so minus 90 to 180, and on this axis we can see that the intervals are increasing in 45s. Let's do that. So I'm going to start with my coordinates. So if my function is y is equal to 2 sine x plus 1, if I substitute minus 90, if I substitute minus 45, I'm increasing in 45s. 0, 45, 90, 135, and then 180. So in each case, I'm substituting this x value, or these x values, and getting a y value. So if I substitute minus 90 into this equation here, I'm going to get 1. Then this one, I'm going to get 0. This one, I'm going to get 1. Then 2. Then 1. Then 0. And then 1. And so these are the coordinates. Now let's plot. So minus 90 and 1. So this is my first coordinate. Then minus 45 and 0, that was my next coordinate. 0 and 1 is here. 45 and 2 goes there. 90 and 1 would be here. 135 and 0 would be here. And 180 and 1 would be here. And now we just join it with as smooth as a curve as we can. Not too bad. And that's our function, g. Now, question 5.5.1, use your graphs to write down the values of x for which f of x times g of x is less than 0. So here, to get a product that is negative, either one of these functions could be negative. So our options are f of x can be positive and g of x could be negative, or f of x can be negative and g of x could be positive. Now, if we notice the function that we just drew, the g of x, it does not go below the x-axis. So in other words, g of x is always positive. So this first restriction will not apply. So that means all we are looking for is where f of x is negative. And that's going to be our solution. So f of x is negative from this point onward here. So from there to there. And so our solution then is going to read x is going to be between 45 and 180. But x cannot equal 135. Now the reason why I'm omitting 135 is because at 135, g of x is 0. Remember, the restriction or the question asks for a solution that is less than 0. If it's equal to 0, we still cannot take it. It needs to be less than 0. So that would be our answer. Now for 5.5.2, f of x is equal to minus g of x plus 2. So what we want to do here is take this over. And so what we're looking for then is where f of x plus g of x is equal to 2. Now, it's not as difficult as it seems at first. So what we're looking for here is values where one of them is equal to 2 and where the other one is 0. For example, here f of x is 2, g of x is 0. So at this point, f of x is 2, g of x is 0, so 2 plus 0 is 2, that's one option. So minus 45 is one option. If we take a look at this point, g of x is 2, f of x is 0, so 0 plus 2 is equal to 2, so that also works. So this is also another option. Now let's take a look at this one, 135. This is equal to 0, this is equal to negative 2. So negative 2 plus 0 is equal to negative 2. This will not work because the answer we're looking for is positive 2. So the answer for this question is simply going to be x is going to equal 45 and x equals negative 45 degrees. Now question 5.6. Graph H is obtained when f is translated 45 degrees to the left. So if the graph is moved 45 degrees to the left, you are going to add 45. Remember, just like how we had here, we saw that the cos graph was shifted to the left, and so we had a positive p-value. If the graph is shifted to the left, we add. So here we are going to add 45. So the function is going to be 2 cos, and in here we have x plus 45, and now we are going to add the 45. So this gives us 2 cos x plus 90. Now notice the question is saying in the simplest form. So whenever you have cos and you have 90 within a bracket, you should be thinking about a co-function. So what does this change to? So cos will change to sine. Cos of 90 plus x, or cos of x plus 90, equals minus sine x. So 2 times minus sine x is equal to minus 2 sine x. And that's our answer.